All marine propulsion systems share a single common goal: to put power via the propeller to the water. How that power is made and how efficiently it's used is determined by the engine type. There are 4 kinds of gasoline engines used in Mercury products, past and present: 2-stroke engines, 2-stroke DFI engines, 4-stroke engines, and supercharged 4-stroke engines. Here's how each work. All gas engines share some basic components: the spark plug, the piston, the connecting rod, and the crankshaft. The piston moves up and down inside a cylinder. This up and down motion is transferred to circular motion at the crankshaft, which turns the drive shaft and ultimately spins the propeller. On a 2-stroke engine, the downward motion of the piston forces the transfer of a fuel and air mixture from the crankcase. The upward motion of the piston compresses the air and gas to form a highly combustible mixture. When the piston reaches the top of its stroke, the spark plug fires and ignites the fuel-air mixture. The ignited fuel expands and sends the piston downward. The incoming fuel and air mixture also push out the spent gases of the combustion process, and the process starts all over again. Because there are 2 cycles or strokes of the piston inside the cylinder, this engine is aptly named a 2-stroke or 2-cycle engine. A 2-stroke engine has relatively few moving parts, so it's lighter than other types of gas engines. It also has a power stroke every 2 cycles of the piston, which gives the engine more torque. Unfortunately, some of the incoming air and gas mixture is lost to outgoing exhaust, which makes it a less fuel-efficient design. This is the reason conventional 2-stroke engines have a tendency to smoke. The next engine type is the DFI 2-stroke, better known as the Optimax. DFI stands for direct fuel injection because it does just that. On a DFI engine, a direct air injector is placed directly into the cylinder. As the piston moves downward, only air is transferred into the cylinder through the intake, reed valves, and crankcase. As the piston moves toward the top of its stroke, the fuel injector transfers fuel through the back of the air injector, where it mixes with compressed air. That atomized fuel mixture is then injected through the direct air injector into the cylinder. The spark plug fires and the piston is driven downward. The amount of fuel injected into the cylinder and timing of the spark is precisely controlled by the engine computer. This makes the DFI 2-stroke an extremely efficient design. What sets the Optimax DFI 2-stroke apart from its competitors is Mercury's patented atomization of the fuel. The precise size and shape of the gas plume delivers a more efficient and better combustible mixture that squeezes more power out of every drop of fuel. Next up is the 4-stroke engine. On a 4-stroke, air and exhaust ports are replaced with valves, intake valves and exhaust valves. As the piston moves downward, the intake valve opens, allowing a mixture of air and gas to enter the cylinder. At the bottom of the first stroke, the valve closes and the piston moves upward to compress the fuel-air mixture. When the piston reaches the top of the second stroke, the spark plug fires and the expanding gases force the piston downward, stroke number 3. On the 4th stroke, the exhaust valve opens and the piston moves upward, pushing the exhaust out of the cylinder. Hence the name 4-stroke or 4-cycle engine. This example demonstrates a carbureted 4-stroke engine. On an EFI or electronic fuel-injected 4-stroke engine, fuel is delivered under pressure through a fuel injector. As the piston moves downward on its intake stroke, a metered amount of fuel is mixed with air, just as the intake valve opens. This precisely injected fuel gives EFI engines better fuel economy and makes them easier to start in all weather conditions. The last engine type we'll examine is the supercharged EFI 4-stroke, the Verado. The Verado was specifically designed to accept a supercharger. What's a supercharger? Well, One way to get more power out of the engine is to put more gas into the cylinder. But you can't just pump more fuel into the engine because an exact amount of air is required to burn a given amount of fuel. That's where the supercharger comes in. Superchargers force more air into the engine by compressing air above atmospheric pressures. This forced air provides a boost so more fuel can be added to the charge. The more fuel, the more power. On average, supercharging adds 46% more horsepower and 31% more torque than a conventional four-stroke engine. We should mention that the graphic illustrations of these examples do not accurately depict actual Mercury designs. They should only serve as an example of how each engine type works. Now let's move beyond the basics to learn how and why Mercury leads the marine industry with its innovative engine technology.